All right, so what we're going to be doing now is getting into the second part of section 6.1, and today we're going to be going over the radian measure and talking about the relationship between radians and degrees. So a little intro on what exactly a radian is. So this is a unit of measurement. It's very helpful in calculus. So if you go on to study something, where you need calculus radians, you're going to be seeing them. So what exactly a radian is, it looks at a circle in a coordinate plane. So how it works is, let's say, so here's a coordinate plane, and then I have a circle. Okay, so I have a circle. So in a circle, we have, again, a circumference. So the circumference of a circle is 2 pi r. That's just a little reminder from geometry. So what a radian is it's saying whatever the radius of my circle is. So remember, the radius is the length from the center. So it's the center over to one of the points on the circle. So that's my radius. So what a radian is it is a measure that it's whatever the radius of the circle is, that portion of the arc length, so the outer part of the circle, whatever the radius is, that arc length is going to be the same. So that's what a radian is. So the formal definition is a radian is the measure of a central angle theta. So remember from geometry, a central angle is where the vertex is at the center of a circle, intercepts an arc S, so this would be my S in this point, that's the portion of my arc that's being intercepted, is equal to the length of the radius R. So that is my radius here. So algebraically, a radian is theta, so theta is my central angle, so that's going to be this angle right here. So a radian is theta equals my arc length over my radius. So this is going to be important for the next section when we get a little bit more into arc length exactly. But that is the algebraic definition of a radian. And then again, a common number using radians is pi, and then just that other reminder about what circumference is as well. So what I want to do now is relate what we know about degrees to radians. So to start, what I have is, let's say I have my coordinate plane. So from the first section, when we looked at degrees, I know that this is 90 degrees. I know that this is 180 degrees. I know that that's 270, and I know that that's 360. And that's all, again, working in a positive way. So if we remember, a circle has a circumference of 2 pi r. So I have this circle. So that means that if I go around 360 degrees, I've gone around 2 pi. So that is the radian measure of an entire revolution around the coordinate plane is 2 pi. So I have 2 pi. So let's say I stop at 180 degrees. I've gone half of that, which is just 1 pi. So then in radians, 180 degrees is pi. Let's say then I'm only going through one quadrant and I'm stopping at 90 degrees. I take half of pi, so 90 degrees is pi over 2. And then it's the exact same thing for 270 degrees. If I've traveled pi so far and then I go another quadrant, then I've gone another pi over 2, so that is 3 pi over 2. Because remember, 2 pi over 2 is just pi. So here I have 3 pi over 2. So that's a little bit about reference points in terms of radians. So if you are given anything that is between 0 and pi over 2, you're going to be working in the first quadrant, pi over 2 to pi is the second quadrant, pi to 3 pi over 2, quadrant 3, 3 pi over 2 to 2 pi is quadrant 4. And then one other important thing to remember is we will be working with coterminal angles and also negative angles. So sometimes we might have some negative pi over 2. And then negative again goes below the x-axis. And then, so that would actually be down where the 270 degrees is. So it's just like with working with negative degree angle markings as well. So to find the complement to an angle measured in radians, we want to subtract whatever angle measure we're given from pi over 2, because as we know now, pi over 2 is the same thing as 90 degrees in radians. So let's say I'm given something like pi over 6. All I would need to do is subtract pi. It would be pi over 2 minus pi over 6. To find the supplement to an angle measured in radians, subtract the angle measure from pi, because we now know that pi is equal to 180 degrees. And then to find a coterminal angle measured in radians, we want to add or subtract 2 pi from the angle measure. And the reason is because we know now that 2 pi is the same thing as 360 degrees. So, if possible, find the complement and supplement to the following angle measures. So, first thing, pi over 4. So, pi over 4 is in between 0 and pi over 2. So, here I have pi over 4, so I know that it does have a complement. So what I need to do is subtract it from pi over 2. So pi over 2 minus pi over 4. And again, when I'm working with fractions, I need to have like denominators. So I need to convert pi over 2 to have 4 as a denominator. So this is the same thing as 2 pi over 4 minus pi over 4. And so that gets me pi over 4 as a coterminal angle. In terms of supplement, I need to subtract it from pi. So here I have pi minus pi over 4. And again, we don't have common denominators, so I need to get a common denominator. So here I'm going to do 4 pi over 4 minus pi over 4, and that leaves me 3 pi over 4. So when I'm working with pi with fractions, a side note, you do not subtract these 2 pi's. The pi's don't cancel out. Next one, so I have 3 pi over 4. So 3 pi over 4 is greater than pi over 2. So it does not have a complement. So there's no complement there. But it is less than pi. So I can subtract it from pi. So I have pi minus 3 pi over 4. Again, we need like denominators. So 4 pi over 4 minus 3 pi over 4. And that leaves me pi over 4. So pi over 4 is the supplement to 3 pi over 4. And again, we also know that from our first example. We're going to do the other two in class as well. Okay, now I want to find one positive and one coterminal, and one negative coterminal angle. Sorry, that should say negative. So one positive and one negative coterminal angle to the following angle measures. So starting at pi over 4. So again, what I need to do is add a positive 2 pi. Again, we don't have a common denominator. So we need to make this pi over 4 plus 8 pi over 4. And that's going to get me 9 pi over 4. So that is a positive coterminal angle. And then for a negative coterminal angle, what I can do is I need to subtract 2 pi. So I have pi over 4 minus 2 pi. Again, we need common denominators, so pi over 4 minus 8 pi over 4, because 8 over 4 is 2. Pi minus 8 pi is going to be negative 7 pi over 4. So a negative coterminal angle is negative 7 pi over 4. On to my next one. So I have 11 pi over 4. So 11 pi over 4. I add 2 pi to that to get my positive coterminal. Again, we need common denominators. So then if I do both, I get plus 8 pi over 4, and then I get 11 pi plus 8 pi. Just add my coefficients, 19 pi over 4. So that is a positive coterminal angle. And then for my negative, what I need to do is I need to subtract 2 pi. So if I subtract 2 pi, instead of add it, so that's an 8. 11 pi minus 8 pi gets me 3 pi over 4. that is still a positive angle. So just like when we had positive extra degrees, what we need to do is subtract another 360. What we need to do here is subtract another 2 pi. So now what I have to do is I have to do 3 pi over 4 minus 2 pi. So I have 3 pi over 4 minus 2 pi, which is the same thing as 3 pi over 4 minus 8 pi over 4. And so that gets me negative 5 pi over 4. That is a negative angle. So there we go, negative 5 pi over 4. And we're also going to do the next 2 examples in class. So the last thing from this section is converting between radians and degrees. So I might ask, here's an angle that's measured in radians, I want it in degrees, or here's an angle in degrees measured, and I want it in radians. So what I need to do to go from radians to degrees, whatever I'm given in radians, I need to multiply that by 180 degrees over pi radians. And then what's going to happen is, let's say I have pi over 2 radians. So let's say I have pi over 2. Pi over 2 radians. And then I want it in degrees, so I do that by 180 degrees over pi radians. So this is in radians. So what happens is these pi's cancel, and then those radians also cancel. So that leaves me 180 degrees divided by 2, which leaves me 90 degrees. And that's one of the markings that I gave to you for reference as well. And then from degrees to radians, you just flip the numerator and the denominator. So you want to multiply the degree measure instead by pi radians over 180 degrees. And then what's going to happen is, let's say I have, let's go 360 degrees. 360, 160 degrees times pi radians over 180 degrees. This degree marking cancels, so that leaves me 360 pi over 180, and that's radians. 360 divided by 180 is 2, so that gets me 2 pi radians. And that again is another one that I gave you for reference. So always how it's going to work is, if you're going from radians to degrees, those radians are going to cancel out, and then same thing, degrees to radians, the degrees are going to cancel out. So I have convert the following radians to degrees or degrees to radians. So we're going to do 225 degrees. So I have 225. Okay. So I have 225 degrees. And then I multiply it by pi radians over 180 degrees. So again, these degrees cancel out. So then that gets me 225 pi over 180 radians. And then we always need to simplify our fractions to the smallest possible that we can. So 225 divided by 180, the closest that we can get is 5 pi. So we found so we have a common factor of 45. And so my, the smallest that I can get is 5 pi over 4. Now let's do one from radians to degrees. So I have 11 pi over 4. And again, from radians to degrees, what I need to do is multiply by 180 degrees over pi radians. So then we have a radians up here. The radians cancels out and the pi's cancel out. And so now all I need to do is multiply the top. So 11 times 180 gets me 1,980 degrees divided by 4. And then 1,980 divided by 4 is 495. So that is 495 degrees. And we will save the last 2 for class as well.